Advanced Maths Paper 1, 2021, Question 5, memo with explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself, so here are some suggestions for effective revision. Don't practice questions which you firmly know that you can do, rather selecting questions on topics where you know that you'll have difficulties. The only time you start practicing full papers is when you try to reduce your time taken to do the paper. If you become stuck on a question, yes, watch the video. Then it's vital that you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise math is quality as opposed to quantity. It is more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, rather than to complete as many papers as possible. Here's the Confucius saying, which sums that up: what I hear I forget, what I see I remember, what I do I understand. Question 5, we're now into the use of radians. We have two formulae, arc length and the area of a sector. A sector is like a slice of a round cake. So we have a circle, center O, so there's our main circle ABCD, diameter AB, and that circle has a radius of 4. So therefore AO is 4, OB is 4, OC is 4, OD is 4. Circular arcs are drawn through C and D with A and B as center. So there are A as a center. I've drawn through there. So there is your radius to there. Radius to there. And in fact, this arc is exactly the same on the right-hand side. So, some notes. All I've done here, by the way, is convert into the question using only the one side at the moment, because once I've found the size of this segment here, I can find the size of the other segment, which means I know the size of this whole unshaded area, and I can subtract that from the full area of the circle in order to determine the area of the shaded section. Note, just to remind, that is 90 degrees by angle and semicircle. That is 90 degrees there as well. Now, you have a formula on your information sheet which says A equals half R squared theta. And that is the area of a sector. So, for example, here, AC round to there and back, that is a sector. R squared, the radius of the sector, and theta being the angle of the sector in radians. Now we're going to have to do a spot of old Pythagoras here. There are AC equals AD equals AP. And if you have a look here, these are 4 because those are radii. So therefore, by Pythagoras' theorem, 4 squared plus 4 squared, 16 plus 16, 32, so square root of 32. So there we are, square root of 32, square root of 32. There are the lengths of the radii, or there is the radius of this arc centered at A. So now I can find the area of this full segment, this full sector, sorry, and then subtract the triangle. So the area of segment CPD is equal to sector ACPD, so this like the slice of cake, minus the triangle. So the area of the sector is half r squared theta. So therefore it's half root 32 squared, being the radius of the sector, times pi by 2, because we need the angle in radians. That's 90 degrees, which is pi by 2, minus half. And all I'm going to do is base times height. I don't need to use trigonometry because, in fact, we have a right angle there. So we could treat that as the base, that as the height. So it's half base times height. And we can go into a calculator. In fact, we don't even need to really. Square root of 32 squared is 32 halved is 8 times pi, it's 16 pi by 2, and therefore 8 pi. And of course, this simplifies to 16. So therefore, the area of the non-shaded section, I've just found 1/2, just this segment here. So I'm going to double it to get the area of the non-shaded area, and there it is there. Area of the shaded is the circle minus unshaded. So we're going to take pi r squared and subtract the area of the non-shaded we just found. 32 square centimeters.